What up, Union Grove? Today, special treat. First of all, I know what you're thinking. The shirt, I did it just for you guys. I know you guys love it. And we're here in Georgia. You guys love this kind of stuff. So, and it's college football week, so get used to it. Anyway, today we're going to talk about chemistry. So far in science this year, we've talked about atoms. We talked about molecules. The next thing up, we're going to talk about chemical reactions. So, without further ado, let's go to my backyard. Hey guys, so here we are. We're in my backyard, but before we get to see the pool, I wanted to go over what goes in the pool. Okay, and since we're talking about chemistry, everything that I'm putting in is all about elements and all about chemicals, right? So first off, right behind me to my right, we've got salt, and this is basically pure salt. NaCl is no additive to it. It's not used for salting up your food. It's strictly for pools, and they say it's pure, so I don't know how pure it is, but it really is sodium chloride. Okay. Sometimes in people's pools they put hydrochloric acid, very strong stuff and very strong acid. We'll talk about this in a little bit. They also put in baking soda, which is a pH regulator. I'll talk about that in a little bit. Okay. Sometimes some pools they'll even put this stuff, and basically what this does, it raises alkalinity. The higher the alkalinity, the better the pH is going to remain the same, and that's what this stuff is. Okay, believe it or not, we also use borates, since some pools like to use borates, or pool owners like to use borates. And we'll talk about this in a little bit. Next up is some aluminum sulfate. Okay, it's got aluminum, it's got sulfur, it has some oxygen in there. We use this as what they call flocculant, and that flocculant will basically make the pool filter a whole lot better. Okay, sometimes you'll see it in a jar like this. It just says flocculant. This is the liquid form. This is a crystal form. Okay, last thing, in a saltwater pool, you also need a chlorine stabilizer. And this chlorine stabilizer makes sure that it does something to the pool so that the chlorine, once it's generated or once it gets pushed into the pool, doesn't get evaporated, doesn't get lost in the sunlight. So believe it or not, chlorine is very much affected by the sun. Alright, so that's what goes in the pool. We're going to talk about each. But before we can talk about each, we are going to test the water. So, Bennett, you ready? Let's go. Alright guys, so the first thing we need to do is test our water. We need to test whether or not it's an acid or if it's a base, right? And to do that, we do a pH test. And so right now all I'm going to do is take a sample of the pool water and we're going to test the pH. Bennett, put the top on. Put that top on. Don't spill it.
Take it. It's pink.
This right here is a pH tester, and basically what it does is the indicator, which is this red stuff, will indicate whether or not the pool is an acid or if it's a base. Right? And ideally, we want it to be right at 7.6 because that means that it's neither an acid nor a base. Actually, 7 is more of a neutral, but 7.6 is what we want in a pool. And so if you look at it carefully, it looks pretty good. If this was in the red or up here, we would need to use some hydrochloric acid, and I'll talk about how that works. If it were down here, then we would need to add or increase our pH. And that means we would need to add some baking soda to help raise that up. All right, so it looks pretty good. Next thing we're going to do is test out the chlorine. Danny, you want to come do this? Let's see. What do you have to do? Back up. Put it in here. Scoot over.
How many?
Scooch.
How many?
Put 5 drops here. 1, 2, 3, 4, 5.
Whoa.
Good job.
That's really
Very yellow.
very.
Alright, let's take a look at what we got. Alright, so what we want is for this thing to turn yellow. And right now, it looks as though we are right in that ideal zone. So that's perfect. That means that the saltwater chlorinator or the saltwater generator is working exactly how I want it to work. Alright? If it wasn't, then we'd probably have to make a few adjustments. But for now, what I'm going to do is go ahead and the salt is getting pretty low, so I'm going to go ahead and add some salt to the pool, and I'm going to show you what that looks like.
Yay!
Alright guys, so this is my pool, and right behind me is where all the pool equipment is, so I'm going to show you what that's all about. So let's go. Alright, so parts of the pool. To my left, that right over here is a pool heater. Okay, this right here is the pool filter, and inside that filter is a whole lot of sand, which basically filters the pool. This down here is the pool pump. In just a minute, I'm going to turn that on. That pool pump is very important because that's what sucks all the water through this, through all these tubes and into the filter. Okay, right over here, that little white thing right there, that is the saltwater chlorinator. And like I said, that little thing is what controls how much chlorine goes in the pool, and it changes the salt water into usable chlorine. Okay, and that cord leads up to this little computer over here, and this computer is what tells me everything about the chemistry of the pool. And so what we're going to do is turn on the pump, and we're going to see what this thing is all about. Alright, so pump is running. Water sucks in from these two tubes right here, 1 and 2. Water goes in through here. It goes into this pool pump. Pool pump shoots the water up this tube and into this pool filter. And so right now, all the water is being filtered through this sand and then being pumped back into the pool. Alright? So, let's look at this. Right now, this is saying 2,500. And that 2,500 is talking about how much salt is in the pool. Okay? Ideally, you want in between 2,800, maybe 2,900, all the way up to 3,200. And that number talks about 3,200 ppm, which means parts per million. So in other words, for every million molecules of water, there will be 1 part chlorine. And so if I have 3,000, so every million molecules of water, that means that roughly I need 3,200 molecules of salt. And so what I need to do is go ahead and throw some salt in the pool so that this number gets to the ideal number. Alright, so let's get to it. Alright, so my kid's favorite part of this whole thing, is it your favorite too, Bennett?
What?
Is putting salt in the pool. And so I'm going to take that big old bag that I showed you earlier and start throwing some of the pool salt into the pool. Alright guys, so here is the salt crystals. So in my hand, supposedly is pure salt, right? And that salt is also known as sodium chloride. And so we talked about this week, that each little particle that you see here is not a molecule, but it's more of basically a whole bunch of molecules into this 1 grain of salt. So ideally what's going to happen is all of this salt that I throw into the pool, here you go Bennett, all this salt that gets thrown into the pool eventually dissolves. Okay? If you are talking about vocabulary, the salt would be your solute, and the water is your solvent. And so hopefully all these big old crystals that I'm holding in my fingers eventually dissolve and it becomes a solution in the water. Okay? And it takes a while for it to do that. So we're going to go ahead and dump all of this into the pool. Get in, Bennett. Get in. Okay, ready?
Yeah. Mine.
Here, let me dump some over here. Getting in, Bennett? Jump. Almost gone. Alright, so I know what you're thinking. Why in the world do I have gloves on? And these gloves are to help protect from chemicals. I've got some goggles because the stuff that I'm about to play with is
dangerous.
Not really dangerous, but I think you get the point. So I'm going to go ahead and grab it, and we're going to see what this stuff does. So here is the hydrochloric acid. It says over here, danger, poison. So don't play with this at home. It's got an exclamation point, whatever that means, probably because it's dangerous. It says pH control on pools. For other uses, clean stone, masonry, tile pools, and cleaning. So, this stuff I actually picked up at a pool store, and it's meant to control your pH. Alright? But before we talk about pH, let's go see how strong this stuff really is. Alright, so we're here in the backyard, behind the pool, and what I'm going to do is demonstrate how strong this hydrochloric acid is.
How?
Basically, we're here on the sidewalk. Got some dirt on here. Who knows what else is on here? But I'm just going to drop a little bit on here just to show you what it does.
Cool. Why is it yellow?
Why is it yellow? What do you think? So why is it yellow?
Is that stuff yellow or something?
Hydrochloric acid, so it has hydrogen and it has chlorine in it. I guess naturally it's got a yellow color to it. And so, because this is a very strong acid and because of the ions that are in it, it causes this chemical reaction on the sidewalk where everything just starts to bubble. I don't even know what's on this sidewalk, but whatever it is, it's causing some sort of chemical reaction, and that's how strong this stuff really is.
Because I have a...
You can try. Let me see.
It's tiny.
Alright, throw it on top. That didn't do anything.
Can I go get a piece?
Alright, so pool pH. There are two things that go on, two different ions that play a role in the pH of a pool. And that is a hydrogen ion, which is basically H+, and there's also a hydroxide, which is OH-. And so it's a combination of these two molecules that control pH. So as you know, in this pool, we've got water. We got water molecules, H2O. We have some chlorine molecules. We've got some sodium chloride, which is your salt. We have some baking soda in there. We have some borax in this pool. All of that plays a role in the pH of this pool. And so what happens is if we have too many hydrogen ions or too many hydroxide ions, that messes up the balance of the pool. And what that does is it makes it either very acidic or it makes it very basic. And we don't want either of those. We want it to be pretty much neutral, and all those ions that we talked about in the first unit are bound, or they've made some kind of chemical bond with other chemicals that are in the pool. All right? And so if we maintain this, then we also maintain the amount of chlorine that's in the pool. You're also maintaining the clarity of the pool. There's all sorts of things that go on with the pH of the pool. And in order to understand pH more, we're going to start talking about all of the chemical formulas that go on in there and all the chemical reactions that take place when we put these chemicals in the pool. Alright guys, so that's it for the day. That's pool chemistry for you. The only thing left to do is jump in. You guys ready? Benny, you ready? Don't try this with your iPhones, folks, because iPhones aren't waterproof. That's why I have a Samsung Galaxy S7. You ready?